Welcome back. Um, Dr. Lee is with us, Mr. Sharad Arora, and also Mr. Satish Jamadagni. We are also joined by Mr. Adrian, Mr. Pradhan, and Mr. Narendra Nath. This is a panel discussion session on operator trust-enabled security framework. I think we will straight away start with context setting by Mr. Adrian Scrase. May I introduce him? He's a CTO with ETSI with operational responsibility for all of ETSI standards production activities. He has more than 30 years of experience in the telecommunications field, which includes 25 years of experience in standardization. He played a central role in the creation of the third generation partnership project 3GPP and responsible for the operations of the 3GPP product coordination group. He heads 3GPP's mobile competence center, which is an international team of 20 experts who provide comprehensive support to the project. He was also principally involved in the formation of the 1M2M partnership project and oversees ETSI's support to that initiative. With that, I request Mr. Adrian to kindly make his presentation.
Thank you very much, and good afternoon, ladies and gentlemen. Can I just check that you are hearing my audio and seeing my video?
Yes, we are able to see and we are able to hear you loud and clear.
Perfect, then. Thank you very much. I'm indebted to the previous presentations because they've really emphasized many of the points that I'm going to make. So I will be quite brief and just get my key points across. I think we've already heard that there is an awful lot of activity taking place. And ETSI has been mentioned more than once. On the screen, you can see a summary of the activities that I believe ETSI is undertaking in the security domain. You can see that we have a number of activities on cross-domain cybersecurity. We have a lot of activities on securing technologies and systems, and we have a lot of activities on security tools and techniques. And I think the takeaway here is that we certainly cannot be accused of being inactive. There is an immense amount of work and focus on security, which I think really illustrates the importance that we place on security in general. If I look at the result of all of that activity, we really have an end-to-end view in terms of cybersecurity ecosystem, in terms of the protection of personal data and communications, in terms of cybersecurity for critical infrastructures, for supporting the EU legislation, and there is a lot of legislation in place here which we are compelled to comply with. We've already heard about the consumer IoT security and privacy, network security, cybersecurity tools and guides, and of course quantum safe cryptography, which we've already touched upon during the earlier sessions. Now, a little word about consumer IoT. IoT security has been mentioned more than once during previous sessions. What ETSI has done is published a European standard on cybersecurity for consumer Internet of Things. These are really the baseline requirements, bringing together technical and organizational measures that are widely considered as good practice. And this European standard has been adopted also in other regions of the world. And what it does, it really supports all parties, especially manufacturers, in the development of consumer IoT. And it really sort of provides very good background information about the approach that should be taken for consumer IoT and the things that the consumers themselves need to do, because they also have a responsibility ensuring that the way in which they consume IoT is done in a smart and secure way. We've also heard a lot about what's happening in 3GPP on security activities. And again, I don't think we can be accused of being inactive. There is a huge amount of work being done within 3GPP, which is focused in one security working group, SA3, which is our central point then for security aspects. Now, for 5G, we know that we are moving away from the concept of citizens with mobile phones. That's 2G, 3G, and 4G. What we have in the 5G world really is the aspiration to serve new industry sectors. And if we are going to serve sectors like health or banking or automotive, then security really becomes an imperative. It's no longer just a nice to have thing, which is why so much work has been done. And I would point to one Release 16 piece of work, which you will see on the screen, which was really a study into looking at industrial IoT and saying, well, if we are trying to serve industrial IoT services, what are the particular requirements here from a security point of view? Another thing which we've heard about is location services. As location services become much more important for some high-end industrial uses, we have to make sure that the positioning data itself is secure. And finally, here I would add that while in the past we've always thought about public networks providing these services, as we move into the 5G domain, of course, we will have non-public service providers. And it's just as important that the non-public networks are as secure as the public networks. But of course, that requires in itself a specific study. What do you have to do if you're a non-public network? How do you ensure you have the same robust approach to security as have the public network operators? And the way I sort of start to view this, there's a huge amount going on at standardization level, and that's all very well and good. But if we're going to succeed in providing end-to-end security, it requires much more than just standards. We have to rely on the secure development and deployment based on those standards, and we have to rely on the secure operations then of those networks. And if we look at more of the sort of recent attacks, successful attacks, very often it's down to human behavior. It's at the operational level that even though we have very secure products that have been securely deployed, there's a failure in the human aspects of the deployment of those networks. So my point here is we really need to have not just secure standards, but secure development and deployment and secure operations. And more importantly, some feedback loop between all three so that all of the actors can learn from the experience of the others. And by our combined knowledge, we end up with greater security than perhaps we have today. Now, if we look at the way in which algorithms are selected, for example, bodies like 3GPP don't adopt algorithms until they have been publicly evaluated. And I think what we see near here is a need to have that same sort of public scrutiny for our networks as a whole. And it's for this reason that both ETSI and 3GPP have put in place coordinated vulnerability disclosure processes. Now, these are very simple processes. What it means is that if you are a security expert, maybe you could be a university faculty, or you could just be a security geek who has no interest or involvement in actually writing standards, but they have an interest in making sure that our networks are secure. And what we have to provide for them is a very simple means whereby if they do discover a vulnerability, they can make that vulnerability known to us, either in an anonymous way or in a named way. And if after evaluation we find that the vulnerability is actually true, there is a vulnerability, then of course we can give credit back to the people who have helped to disclose that vulnerability. And I would certainly promote that all standards bodies should have this coordinated vulnerability disclosure process in place. Our early experience shows that where we have bright academic students who are looking at security for their studies, very often they are the source of discovery of vulnerabilities. And it's only right that we provide a mechanism for them to inform us of that, and that if they so wish, we can give credit back to them. Time for some conclusions then. We see that for many industry sectors, robust security is an absolute imperative. That's very clear. We can note that there is considerable security work being done at the standardization level to address these needs. But standards alone are not sufficient. They must be complemented by secure deployments and secure operations. And we need to have feedback loops in place to ensure that we learn from these experiences. And with that, Chairman, I will stop.
Well, thank you. Thank you very much, Adrian. Thank you for describing the 3GPP activities in 5G, and also your catchword that not just security, but secure operation and secure deployment. There has to be a mesh or triangle of all the three to ensure total security. Thanks for that context setting. Ladies and gentlemen, as I said, that we have also joined by Mr. Narendra Nath and Mr. Amit Pradhan. I will just introduce the two panelists before we go for question and answer sessions. Mr. Narendra Nath is an officer of Indian Telecommunication Service. He's working as Joint Secretary, National Security Council Secretariat, with responsibilities for coordination in matters of cybersecurity activities by different entities of India in the government, public and private sectors. Prior to this, he was Deputy Director General, Department of Telecommunications, Government of India, with overall responsibilities for the policy formulation and implementation and matters pertaining to telecom network security in India. He has over 30 years of telecom experience, including 20 years of senior management experience in the area of telecom security, network planning, installation, operation, and maintenance. He was associated with TSDSI as member of the governing council. He was also a director on the board of Tata Communications Limited and is currently on the board of NSCS. He holds a master's in technology from Indian Institute of Technology, Delhi, with a specialization in VLSI design. Welcome, Mr. Narendra. And I also welcome Mr. Amit Pradhan. Mr. Pradhan is the Executive Vice President, Technology Security, the Chief Privacy Officer and Chief Technology Security Officer at VI, one of the largest telecom company in APAC. He holds one of the largest security portfolios in the country, which includes telecom security, IT security, data privacy and protection, and enterprise security. With close to two decades of experience, he has spent most of his time in the areas of security strategy, transformation projects, security operations, and advisory role. He specializes in security strategy and cyber incident response and forensics. He is recognized in the industry for his security initiatives and as security strategist. He frequently speaks at domestic and international forums on security. He has been recognized and awarded for his contribution to the security fraternity by various industry fora. Welcome, Mr. Pradhan. I have questions for the speakers, the panelists today. In the first session, we had presentation by Dr. Lee. So my first question goes to him. Dr. Lee, what are the main threats to encryption security systems from quantum computing? What is the timeline of these threats and what must be done? Dr. Lee.
Okay, so regarding your questions, so actually I have concentrated on quantum computing. However, the security point of view, there is no big changes or differences, I believe. So still there are certain particular threats, such as disclosure or modification of stored data, some cases distortion of stored data, and then disclosure of the data during the transition or transfer of data. So the issue is, in case of quantum computing, it's more complicated. So compared to the conventional bit generated key. So actually, quantum computing, so we are considering qubit. So it's totally different mechanisms, and it's also very complicated and very difficult to know the details. So in this regard, it's more secure, but still we need to think about how we protect this kind of threat and then how we reliably deploy various kind of infrastructures. Actually, your question also related to lifetime issues. So actually, from the generation of data to consumed data, it means that from the center to the destination, you always need to maintain and ensure secure and reliable transactions. So this kind of a full life cycle management for security, including privacy also, a very essential part. Lesson 3, trustworthiness. So this one is more broad concept compared to the already security methods. There are lots of additional considerations, such as reliability, some case safety issues. That kind of things need to be further considered. Finally, I also have some strong concerns because currently we are using existing network infrastructures in case mobile, such as 4G, recently 5G networks. And many network operators, they have their own legacy networks. The issue is how they deploy, how they support newly quantum computing environments. The first step is how to interconnect quantum distribution networks, particularly for supporting security methods. So in this regard, very urgent thing is to think about various kind of challenging work for integrating between corrupt networks and then quantum key distribution networks. So I believe it's a really important thing. In this regard, currently ITOT is considering a new work item to cover this topic. Thank you.
Thank you very much, Dr. Lee. I throw the same question to Mr. Amit Pradhan. He may like to supplement.
So thank you, Mr. Srivastava. I will take a little different approach here to talk about quantum computing, right? From a practitioner's perspective, I would say the biggest problem apart from technology is revamping the already established security estate across the country, right? Now, let me say from a layman's perspective, quantum computing is like advancement of computing power, and it brings along all the regular risks that we know which an enhanced computing system could bring in. Now, while we see that the advantages definitely overweigh the risks, and that is why we see such rapid adoption, it is just not advancement in computing. It is about the whole design. Now, while Mr. Lee and Mr. Satish covered a lot of details on distributed key, standards and possible risks, I think there are two risks that we should also consider. So one is, as I said, we already have a huge estate of public key infrastructure using keys across various financial institutes, national critical infrastructure companies, and other corporates. And in a short duration of time, when we have commercially available systems, the entire setup might get obsolete. And let me give you an example. Let us consider an RSA 3072-bit key, which is usually used in a PKI setup. Even today, there are algorithms available which run on quantum computers, which reduce this 3072-bit key to a processing of 26-bit key. And now you tell me how much time, even in today's computer, would require to break a 26-bit key. And essentially, most of the PKI, public key infrastructure algorithms widely used today, they rely on these. So they will get useless. I think that is probably the most biggest risk as an industry, as a company, as a security function that it will face. Now, additionally, with excess of computing power, there are upcoming technologies which are used for security penetration. Like one of them is profiling. Profiling requires a lot of data crunching, right? Attack scenario simulation. I think these are the things where quantum computing will bring in a visible difference to the adversary to gain advantage over all the security functions that are available today. And I think we talked about the timelines today, right? Somebody said 3 years. I think in one of the presentation I said I saw 5 years. But I believe it is much lesser than that. We already have quantum computers today available, semi-commercially available, right? So the reality is there. I mean, it's no more a futuristic thing now. Unfortunately, the security practitioners like me today have limited knowledge about quantum computing. While we have a lot of people who talk about it, when it gets down to people like me who actually use products and solutions to apply these principles to protect the company and thereby the country, we are still not equipped to understand the effects of quantum computing. And I think that again is a big risk that I see.
Okay.
Now, obviously, there are algorithms that are built which are quantum safe algorithms, and the designing is again being relooked at with various standards. I think with these, along with these risks, we'll be able to manage the adoption of quantum computing in future.
Thank you very much. That was very comprehensive reply. My second question will go again to both the service providers on the panel. First to Mr. Satish Jamadagni. The security components within the GSM core network are the rock-solid foundation based on which mobile calling, roaming, and VAS services have proliferated safely across the globe. Is there a learning for the security enablement for the arriving 5G networks, new age service providers, and IoT devices? So I'll request Mr. Satish Jamadagni to briefly respond to this, followed by Mr. Pradhan.
So are we talking about, sorry, I'm just trying to understand your question.
If you wish. Topic, is there a learning for the security enablement of the arriving 5G networks, new age service providers, and IoT devices, in the backdrop of what we have done in the past with regard to GSM core network, various roaming and VAS services, so on.
Yes. So in the case of GSM networks, or even 3G, even 4G networks, anything that uses SS7 in the backhaul, one of the big learning was that over a period of time, security gaps have been addressed, and it has been accumulated into what is called as the SS7 secure gateway. There's a firewall which is evolved over a period of time. GSMA has spent quite a bit of effort in trying to collect all these vulnerabilities, and they've done the same thing over a period of time. And this is an accumulation over a period of time. The same is not true for Diameter or any of the new 5G protocols. It will take some time. So in the meanwhile, there are certain vulnerabilities which 5G networks can face. Now, for example, if you look at a Diameter gateway, a Diameter firewall versus SS7 firewall, SS7 firewalls are very, very mature today in the market. You can just go pick up a gateway today or a firewall today and have it up and running, and you're fairly secure. Same is not true for Diameter. So it will take some time in the meanwhile, that is where the gaps lie. So the onus will be on the operators themselves to plug all those gaps and make sure they have the right firewalls in place. This is one of the key learnings.
Thank you. Mr. Amit Pradhan, would you like to supplement?
Sure. So, I won't talk much about the 5G security because you already spoken a lot on it, but I'll just pick up one case about IoT being used along with 5G. And that, I believe, will bring three significant risks to the table, right? So, one is identity and accountability management. And I'll give you an example on it. The second is visibility and detection. And third is incident response. Now, these are all normal terms, right? Common terms we hear when we talk of security. But the whole game changes when we talk about IoT, because suddenly we have not only million devices talking, but we have multiple entities involved in an IoT-based service. And let me give you an example based on my experience. IoT ecosystem typically will have entities right from sensor manufacturing companies to the software provider, the IoT platform provider, the TSP, the telecom service provider, the target infrastructure, which is to be monitored, the company that, and finally the monitoring entity. And I'm yet not talking about the regulators and the regulatory supervision on this. Now, with so many entities involved, and with adoption of digital platforms and its penetration in the operating and IT technologies, investigation of a cyber incident or a fraud becomes a nightmare. And while we have all the protocols and firewalls and security solutions in place, I think the task at hand becomes difficult more because of all of these entities using technology. Now, when we talk of increased visibility, we consider not only generating of logs, but also improving our capabilities on integrating cyber intelligence with monitoring systems, with OT systems. When we talk about better detection, we are talking about how well can I spread my detection capabilities over IT, OT, SCADA systems, and then developing context-based use cases to identify a real anomaly, not some false positive coming out from these million devices connected and throwing data. And then we are talking about faster response, because now if my cyber defense center is going to have 1 million events getting generated on the screens in the initial year, how will I develop my practice to look at those critical, priority elements and then respond to them? I think these are the things that we have learned while implementing few of the IoT projects. Playing one of the entities in the 7-8 entity chain, and it is kind of really interesting.
Thank you very much.
Srivastava.
Now I have a question for Mr. Adrian. Mr. Adrian, you have concluded, I just read out that, but standards alone are not sufficient. They must be complemented by secure deployments and secure operations. So what can be a possible approach to ensure uniform, interoperable, and secure operation? How can the provisions of the mandatory testing and National Trust Center be realized in the context of wide range of connected devices and applications that exist in diverse ecosystems? Mr. Adrian.
Yes, thank you. I mean, as I said during my presentation, standards are a very good starting point, but they're not the ending point. So there's an awful lot more to be done than just write very good standards. But I think it is credit to the standards bodies, the amount of work they have done. But then taking those standards and making sure that the products that are produced to those standards comply, making sure that when those products are deployed, they are deployed in a security conscious way, and that they are operated in a security conscious way. I mean, that needs all of the endpoints to be tied together in some way, shape or form. And I think approaching each of those 3 points separately is probably not the answer. I think we do have to have a very joined up way to address security for the future. And we don't really know quite what's going to happen with 5G. I think we're entering into a little bit of the unknown. We've got lots of examples of what could be increased threat vectors for the IoT market. But until we start to get real life experience of deployment in these domains, we're not really going to know quite, what we're facing. So I think we need to be very agile. We need to have a very good way to gather and share the information that we obtain during the deployment phases, and be ready to act. And I think if we come back to the discussions we've heard about quantum and quantum threats, I think it's very much the same there. We know it's going to happen at some point in time. What we can argue about when it's going to happen. Some say it's now, some say it's 2030. But we have to be able to move very quickly so that when the threats are realized, we are able and agile enough to implement the patches and bring about the change that will make our network secure. We have this security by design, which we've spoken about today, which is a very, very good approach to the future design of networks. But we just have to be able to move very quickly as and when threats are realized.
Thank you. I think I will lob this question towards Sharad. Sharad, would you like to say something? Your audio, please. Please unmute, Sharad.
Thank you very much. Thank you, Mr. Srivastava. I think what Adrian just said is taking on from there, and I'll do it in less than 30 seconds. The only way we can actually handle an incoming threat is when we have prevented it before it has struck us. I have handling IoT. I wanted to say that there are two TSPs and I am an IoT service provider. I see the challenges of handling everything non-standard. All the devices are non-standard. All the firmware is non-standard. They don't understand what is SIM toolkit. They don't understand how to respond to a GSM APDU. Frankly speaking, telcos and IoT service providers are going to end up as two totally different animals, and we are going to end up with totally different problems. And what Mr. Pradhan said, I think I would just say that really our only choice is what you, sir, as chair, said almost 3 years back. I think we should act along lines of good standards to put together preventive mechanisms. That's the best I can say from my experience. Thank you.
I think the role of system integrator will also be enhanced, because that will become a very critical role in this environment. My next question is for my friend Mr. Narendra. What are the most significant cyber security concerns for the proliferation of IoT in smart cities, etc.? Narendra, because you are working in the government on this issue, so please explain it to us.
Yeah, the IoT, my co-panelists and the speakers earlier, and especially Mrs. Srivastava, have really covered in detail, the requirements for IoT security. And one of the other things that was pointed out by Adrian was regarding, deployments, standards, deployments, and operations, to work together. So the issue here is, I think, to supplement to what Mr. Adrian has said, I think one other thing is adoption is also an important part. I think instead of having a triangle, you should put a quadrilateral there, and then, put adoption also. Because what is the incentive currently for any IoT device manufacturers to incorporate security into the device when it does not create a level playing field for him? Because if he spends extra money on creating a security profile which is required for the device, he's costed out of the market.
Yeah.
Because the user who is going to purchase the IoT device is looking at the cost of the device, and he might not be really interested that if his device is compromised, his work is getting done, but the device is actually being used to attack other critical infrastructure. So from the national security perspective, that is a cause of concern, that you might come up with standards, you might come up with guidelines for operations, you might come up with hardening for deployments, but still, you would find that there will be no uptake of devices, secure devices. So this is one area I think that is to be worked on. There's a lot of activity that has happened in terms of, we have proposed for the National Trust Center. I think that the framework that Mr. Sharad Arora had proposed is something that I think we should work on. And the government has a big role to play in this. To see that we create the necessary legislative, regulatory framework which makes it mandatory for secure IoT devices to be deployed.
Yeah, we are doing that. Thank you. Thank you very much. Thank you very much for the clarification. I will request the host. I think there has already been a buzzer. So I wonder whether we have a couple of minutes time to take up one or two questions that are there in the question section, or we run out of time. Host, please respond. Yes.
So now the time is 6:48. We would start the next session by 7:05 in the another link. So I will leave it to you. I leave it to Mr. Sharad.
May I suggest, Mr. Srivastava, that we take one last question, but we try to limit it to 2 minutes, because Bindu has said that 6:45 can maximum go to 6:50. They have to do some back housekeeping. So maybe you can take a last question.
I will take a question from this question, question section. Oh, attacks. This is Mr. Sesh, Professor, Amrita University. Attacks from bad checked actors is also part of the analysis as outlined by Mr. Pradhan. This is often not discussed in 4G. In 5G, critical infrastructure can be brought down. So I think we have spent enough time on this question. And any thought on foolproofing security measures to check accountability, say when telco provider withheld emergency dialogue? This is from Mr. A. Vinod, semiconductor professional. Quickly, if we can hear from either of the service providers, maybe Mr. Pradhan, would you like to address this question? Any thought on foolproofing security measure to check accountability, say when the telco provider withheld emergency dialogue?
No, I'm sorry, I don't understand the question.
Okay, I think we'll pass the question. So with this, I think we will close this session. I thank all my co-panelists for their wonderful, points of view, a very clear thought process. And as Mr. Sharad was saying, Telecom Engineering Center is in the process of setting up the National Trust Center, and we will ensure that security by design is implemented. We are doing a lot of work as far as security of other telecom elements networks are concerned, but it is the IoT which is of maximum concern to us, and we'll see to it that we set up a wonderful center so that every device that goes into the Indian telecommunication network is properly tested and there is no compromise whatsoever as far as security is concerned. So thank you very much, my co-panelists, and also ladies and gentlemen who are attending this webinar. Thank you and bye-bye. Good night.
Thank you very much.
Thank you.
Thank you, Adrian, and thank you, Dr. Lee. We are very grateful for your time and also for all the efforts that you made to be here with your presentation. Thanks a lot. Thank you, Dr. Lee.
Thank you. Thank you. Bye.
Bye-bye.
Thank you, Ji.
All right. Thank you everyone to have joined us for this panel discussion and for such a lovely panel discussion what we had today. And thanks to all attendees who are also here patiently witnessing the panel discussion and asking the questions as well. And now I request all the delegates to join the second session of the day on data management and privacy in the digital era. That will be starting by 19:05, that is 7:05 p.m. And we'll be sharing the link in the chat box. So I request you to click that link. Probably you can exit from here. You can copy the link and you can exit from this year meet and you can join us in the other link as soon as possible. And we will start the session by 7:05. Thank you so much. MTRK signing off here.
Bye-bye.